Uh, Hello. Good morning, everyone. Let me send the message. Okay, we have still time. Near 25 minutes. So we will carry on. Let me send the message. So here only Harjot, Vikramjit, join now, and Abhijot. So you can provide the feedback those who have joined, right? So server was down for these few minutes. So we were doing this question here. What is the question? AC diagram is not given. We have to draw the diagram, right? And here we have to join now this angle CAD. CAD and angle CBD. We have AC as a common hypotenuse and triangle. One is ABC, right? ABC and one is ABC. These two triangles. So here they are asking ABC and ADC are two right triangles with common hypotenuse AC. Prove that the point of prove that angle CAD and CBD you have to draw in this way. CBD. So join this angle, that is angle CAD, and this angle, that is CBD. These two angles we want to prove that these two angles are equal, right? And this is a application based question of circles. Here AC is the common hypotenuse. What is given? AC is the common hypotenuse. Is the common hypotenuse of this triangle ABC and ADC. Now here angle B and D, they are 90. So here this ADCB is a cyclic quadrilateral. What is it? Here, so here what we have, ADCB, name I have changed, ADCB is a cyclic quadrilateral. What is it? Cyclic quadrilateral. And if it is a cyclic quadrilateral, so there is always one circle which will pass through these 4 points and angles on the same segment from these 2 points B and C. The angles on the same segment, you will write angle CAD is equal to angle CBD. You will write here explanation because they are the angles on the same segment. If you are not understanding, let me discuss. There will be one circle which will pass through all these points, right? There will be a one circle, right? In this way, which will pass through. So here from C and D, both angle 1 and angle 2, they are equal. So with this, we have completed our chapter. Those students who are live, so Abhijot Singh, okay, I have not sent the message. Harjot, okay, Harjot is watching. Thank you, Harjot. So we have 3 students those who are watching. So due to there was some problem in the server, okay. So internet issues. So any other doubt, like there was a disruption. If you have any question from this complete chapter, otherwise I will start now the construction. In construction, we will take very first exercise, and in very first exercise we will learn, or we can recap in your previous classes like grade 6, 7 and 8, how to construct the different angles. Okay, one more students join the class, right? So here I think is Abhijot. Thank you Abhijot. ADBC is a cyclic one. Again some buffering has started. Okay, came normal. So start with the new. I am waiting for sir explain question 8 of exercise 10.5. Thank you Arjun. If a non-parallel sides of trapezium are equal, prove that it is cyclic. Question number 8, 10.5. Question number 8, exercise 10.5. Explain that. Question is explain that if the non-parallel sides of the trapezium are equal, prove that non-parallel sides of trapezium are equal. If the non-parallel sides of trapezium are equal, prove that it is cyclic. Prove that it is cyclic. Right? So to prove it's cyclic, we have to prove that a positive just any trapezium is there. Okay. When it is cyclic, like it is A, B, C, D. How we are saying this cyclic? Only when we have angle A plus C, that is 180, and angle B plus D, that is also 180. Supplementary. So here in this question, only the statement we have that non-parallel sides. These two sides are parallel and non-parallel sides are equal. So we have studied, that is our acquired knowledge. In chapter 8, quadrilateral, we have question number 12. Let me discuss with you. If you forgot page number, come to the exercise 8.1 last question. 8.1 last question, that is question number 12. Okay. Exercise 8.1 question number 12. Let me show it here. Right? This is the question, and they have this one here, this one question here. At page number 147. So they have discussed the same question, but with the help of this question, we know when we have a trapezium in which the two sides, that one is A and one is B points, and this C and D, they are equal. This C and D, they are equal sides, right? These two sides are equal. A, B is parallel to CD, and what we have given, we have this AD is equal to BC. So we have already proved in that case angle x and angle x, they are equal, and this I have 180 minus x, because these are the linear. If we have the two parallel lines, like here these are the two parallel lines, and here we have this transversal, these are co-interior angles. If this angle is x, this is 180 minus x. Same is the case here. This is 180 minus x and this is also 180 minus x. And we have proved why these two angles are equal. Why angle D and C are equal, and we have also proved angle A and B are equal. In that question 12, even so many things they have asked in that question. Even they have asked the triangle in this way, and how they are proved? They are proved by joining one line, then making one parallelogram here equal. So parallelogram, this angle and this angle, they are always equal. Here this is the, if two sides are equal now, this angle is also equal and these are alternate angles. So if it is x, this angle is x. If this is x, it is also x, and this angle is also x. Same, directly from our acquired knowledge, if we have a trapezium and the non-parallel sides are equal, then the base angles are equal. If we have the equals, we can write angle B is equal to angle C. Okay, let it is equal to x. And what is angle? Angle A plus angle D? 180. Right? What is angle B plus C? Why they are 180? These are co-interior angles. Co-interior angles. Right? So here, if angle A and B are, they must be equal because C and D they are equal. If they are equal, this is also x here, and this we can write as x. So what is angle A? Angle A can be written as 180 minus x, and angle B can be written 180. So both angles are same. You can write like these are y. Okay. Now what we have? Let these angles either in the same way you can write. If we add all, what we have? We have that this angle is y and this angle is y because both are equal. So what we have here, this implies that angle A plus angle C, that is also 180, and angle that is your D and B, angle A, angle D, that is also 180. Why? Because we have already proved x plus y is 180. So this is the question. It is important one, but you have to explain this very, very logically. I hope, Arjot, if you are clear with it, you can provide me feedback. Okay? So I am not like a very systematic way, just the acquired knowledge. I am assuming that these two angles are equal, D and C. If non-parallel sides are equal, then these base angles must be equal. And if these base angles are equal, then because x plus y is 180, so here also this angle should be equal, A and B. Now if these two angles are x and this one is y, so x plus y, like co-interior angles, we can go for that x plus y is 180. Okay, thank you Arjot. Arjot provided the feedback. So here we have so then I've done this question. Thank you Arjot. Now construction. I hope you are having your geometry box. Without geometry box, you cannot think of the construction. We have two exercises, 11.1, 11. In chapter 11, we have one is exercise 11.1 and another is exercise 11.2. So first, this is a very basic about the basic angles. The main concept here, again we have two concepts. One is the perpendicular bisector of line segment. Perpendicular bisector, and another is angle bisector. And for angle bisector, you should know first how to draw the angle. Like angle of 30 degree, 15 degree, 60 degree, 45 degree, 90 degree, 75 degree. All these angles, although we have learned 120 degree, 150 degree, 60 degree, 90 degree, it's half 45 degree, 20, two and a half, right? Like here 30 degree, 15 degree, that is 7.5. So how you can, if you know draw a 30 degree angle, its half will be 50 degree. Its half will be. So here, how to go for 75 degree? If you know how to draw angle of 150, right? So 150 half is what, 75 degree. So you should have the clear knowledge how to draw these angles. So we will start with the very basic concept, how to draw a line segment, how to draw the perpendicular bisector of line segment, and then to the angles. Okay. So here we will start with perpendicular bisector. Okay. Sometimes question is in the final examination also. So if question is, you have to draw a line segment of 8.7 centimeter and divide it into 4 equal parts and divide it four equal parts. Even if you have question can be divided into 2 equal parts, or question can be perpendicular, draw its perpendicular bisector. Draw its perpendicular bisector. But when we are going for this 4 parts, then we have to do it for 2 more times. So with the help of scale, let one point, that is A here, and with the help of this your ruler or scale, let this distance AB is your 8.7 centimeter. Now what we will do? We will open the compass more than half. Suppose half is here, we will move more than half and we will make one arc. Right? Same arc we will make from point B. We will not change the length of that arc. Length of the arc will remain the same. Okay, but fix the middle at point B and we will make the arc in such a way. Okay, so here now these 2 points, with the help of scale, we will join these 2 points. This perpendicular line is your perpendicular always. It is making 90 degree here. Now this part, this is always the midpoint and this angle is always 90 degree. So here what is it? AM is equal to BM. But here, if you want to divide it in 2 more parts, these 4 equal parts, we have to do this process again for AM and BM, right? For AM and BM, again open the compass more than half, right? And from this side also, and where these 2 points intersect, we will join this point here and this point is N here. Now what we have? We have this AM is equal to what we have? Half of this, that is AN is equal to MN. Similarly, this side also perpendicular bisector, you can find that this point is P point. Okay, this angle and this side PM is equal to BP. BP is equal to your PM. In fact, all these four they are equal, right? AM is equal to BM, AM is equal to BP is equal to your PM is equal to M. All are equal. Why? First, we have divided AM and BM and then their half. Their half, that is AN, MN, and so all these four they are equal. This is about your perpendicular bisector. Another is angle bisector. If we have, this is about your angle bisector. This concept, that is first angle bisector. I hope you all are clear with the angle, that is the perpendicular bisector, and second we will discuss the angle bisector. If I have one angle, this is a point like O, okay, and we have the angle A here, AOB. How to divide it into equal angles? That is angle bisector. Here, this is the perpendicular bisector. This is perpendicular bisector. Okay. So here we have the angle bisector. I hope it is very clear. Although this is the application based question, 3 marks question is coming in the exam on 4 marks that divide a particular line segment into 4 equal parts. So here we have studied, this is the concept of perpendicular bisector. So we have the two concepts in the first exercise. One is the perpendicular bisector. Perpendicular bisector. Perpendicular bisect means two equal parts. To cut, to divide into equal parts. Perpendicular bisector, if we have a line segment AB, so we have learned how to draw first one arc here from point A and same length of the arc from point B, and where this join, this is called your M is the midpoint and perpendicular. Whereas angle bisector, how to go for the angle bisector, what we will do? With the help of compass, we will from point O, we will mark one arc here. What we will do? Here, this is the angle AOB, right? And this is, with the help of compass, mark one arc here. What I have done, and after marking K, you have to open the arc more than the length of half of this length. Okay. What I have done, I have drawn one arc, right? Now from here, open one arc more than half of it. If this is a distance more than half, you can make a bigger one, no problem at all. From these 2 points, one, right? One arc from this point, and say now we will not change the length. We will then mark so after measuring these 2 arcs, we will join the point here. Now what we have, if this point is point C, then we have angle AOC is always equal to angle BOC, right? Or we can say the ray The ray here, that is OC. OC is the angle bisector of this angle. What we have in the angle initially? Initially we have angle AOP. Now we have two angles. One is angle AOP and both are equal. And if we add, we have angle AOP. So this is the basic concept. So as a homework, what you can do, you can start with drawing the angles. Tomorrow I will discuss the angles with you people. They are angle of, like your how to draw 120 degree, how to draw 60 degree angle, 30 degree, 90 degree, 45 degree, 75 degree, even half of them. So all these angles we will do, right? So with this, thank you very much. God bless you all, and those students who are in the group evening, you can please join, and rest I will form the group for the morning also. Thank you very much. God bless you all.